All right, let's talk about slope and how to calculate slope. Okay, so um, we just talked about something called constant of proportionality. Okay, and that's really similar to slope, but slope has specifically to do with graphs. Okay, and we're going to use something called, or the letter m. Okay, the variable m to represent slope. Okay, now it's similar to constant proportionality, except it's a little different because the constant of proportionality could be a different number than well, no, it wouldn't be the different number from the slope, but slope is different than constant of proportionality because a slope can represent a line that doesn't go through the origin. Okay, so your line might not go through 0. And let's look at what that might look like. Let's put a few dots here on my graph. Okay, and so my graph's going to go like this. Okay, what does this mean? Okay, how do we calculate the slope? The slope is the steepness of this line right here. Okay, what is its, how steep is it? All right, and and there are positive slopes and negative slopes. So a positive slope is one that goes from left to right, goes up, right? Like as if you're walking up the stairs. A negative slope would be one that goes down from left to right. Okay, you would call that a negative slope, and it would be represented by a negative number. Okay, so let's look at this particular slope. The way we would figure out slope is, and I'm going to use this little triangle. What that means is that's change. Okay, so it's the change in y divided by the change in x. Okay, or we can say rise over run. Okay, so rise being that direction, okay, going up, or in some cases down, over run, going left to right. Okay, so what we can do is we can take some of these ordered pairs. Let's look at these and let's write them in here so we have an idea. So we always put the x value first, right, when we're ordering pairs. So this plot point says 2, comma, what, 2. You think, oh, that's easy. That should just be a slope of 1, right? But what we need to track is the change in y. How much does it go up divided by how much it goes over? Okay, so in this case, we're going to look at another ordered pair. Let's take this one over here. All right, and we got, see, 4, 5, 6. So this is 6, and I've got an ordered pair of 6, comma 4. Okay, well that looks a little different. All right, so how do we figure out the change in y? Well, how much did it change? We went from 2 to 6, 4. So it changed from 2 to 4. Or we can just count it this way. We went, here I'm going to do it in red so we can see it. 1, 2. We went up 2, or positive 2. The other way we could have done it is by taking the ending value and the starting value and just subtracting them. Okay, so 4 minus 2, and in this case, ending value, starting value, 6 minus 2, and we would get 2. Okay, so there's 2 different ways we can do it. All right, we can just look at the plotted points and subtract the difference, find the difference. Okay, starting with the last point and subtracting the starting point. All right. Then how much did we go over as we went over 2? Well, I could look at it this way. 1, 2, 3, 4. It looks like we went over 4. That's our run. or like I showed earlier, 6 minus 2, which is also equal to 4. So it looks like my slope is 2 over 4. Okay, 2 over 4 can be reduced, right? 2/4 is the same as 1/2. So my slope, m, is equal to 1/2. So now we've been able to see how that works. Let's look at a negative one so that we can do that. And I just want you to remember, change in y divided by the change in x, or rise over run for slope. And slope is represented by m. Let's do another one. Let's put one in here. And what we're going to do this time, and I'm going to just do all 4 quadrants. Sorry, this is really messy. All right. And what we're going to do is we're going to have a, let's see, plot point there and plot point there. Okay, so now our line is going negative, right? It's a negative slope. It's heading down. If we're looking from left to right, we can see that it is going down. Well, let's look at our 2 plot points. Let's call this 1, 2, 3. And 1, 2, 3, 4. Okay, so it looks like we have 2 ordered pairs. We've got 0, 3. And then down here we have 3, 1. What is the change? Okay, m, or slope, is equal to the change in y over the change in x. So let's start with change in y. Change in y, we went from 3 to 1. So I'm going to represent that by taking that second number, 1, and subtracting the first number to get the change. Well, that would be 1 minus 3. Well, now we're going negative. That's weird. Okay. But that's what it says. And hence, we have a negative slope. You should have a, if the line's going down from left to right, your number should be negative. All right. Well, let's see what happens at the same time. What's our change in x? Well, we went from 0 to 3. And again, we can take that second number and go 3 minus 0. Okay. 3 minus 0 is 3. So now we have negative 2 over 3. So that is our slope. M equals, and we can write it this way too if we want, negative 2 over 3. And now we can use that in a formula, which we'll talk about later, called slope-intercept form, and plug those numbers in and be able to determine what any value for y would be if we know what x is. Okay, or vice versa, really. So that is how you would find the slope for a negative slope. And again, what you can see, this is different than k, because there is no k. These don't have, they're not constant. They're not proportional. Okay? So that's why we're going to use m for slope.